Welcome to inverse functions. In this section, we're going to look at inverse functions and inverse trigonometric functions. Let's review some of the rules for an inverse function by first looking at the definition of a function. A function is a special type of relation or correspondence that takes or assigns each member or element of a set, called the domain, to exactly one member of another set called the range. A relation is a function if and only if no vertical line intersects its graph more than once. So if I were to draw a function, anything like this could be a function. But if I were to draw something like this, we do not have a function because a vertical line could pass this curve in 3 different places. Whereas if I throw a vertical line up here in any other place, on the first example, I never touch the graph more than once. A function with a domain A is called a one-to-one function if no two elements of A have the same image. That is, if you substitute a value into the function and then you substitute a different domain value into the function, as long as the two domain values don't equal each other, a function is one-to-one if, and only if, no horizontal line intersects its graph more than once. So now if I were to look at the example I gave you before, you would see that this function is not a one-to-one function, because if I draw a horizontal line along this curve, there are multiple points at which it crosses the graph. So now we have to figure out how to define the inverse function based on this understanding of a function and a one-to-one function. A function is one-to-one if and only if no horizontal line intersects its graph more than once. But if I were to look at a sine function, we can see that it clearly would not be one-to-one because every period the graph will hit in multiple places for that horizontal line test. The inverse function of the one-to-one function f is defined as f inverse with that little -1 up there equals the set yx such that xy belongs to the original function f. In other words, f inverse of y equals x, which implies that f of x equals y. So f inverse is the rule that reverses the action of f, and hence, I know we don't use that word that often, but because of this, the domain of f inverse is the range of f. And the range of f inverse is the domain of f. The graph of f and f inverse are symmetric with respect to the line y equals x. So let's say I take a little piece of the sine function. Notice that if I draw a horizontal line here between 0 and pi, we'd intersect in 2 places. So what I'm going to do is I'm going to extend the sine function to the negative side of x and do another horizontal line test. And notice that it crosses in 2 places down here as well. So what if we were to restrict the domain of the sine function so it went from negative pi over 2 to pi over 2? Would that pass the horizontal line test? It would, and in fact, that's how we have to restrict the domain so that when we flip the graph over the line y equals x that I'm drawing here, in gray, you can see that the sine function would flip and we would have something that looks something like this. So it's a reflection, and literally if you get a mirror you can check this. It's a reflection about the line y equals x. Inverse function property states that f inverse is the inverse of the function f if and only if f inverse of f of x equals x. For all x in the domain of f and f of f inverse of x equals x. For all x in the domain of f inverse. That's a lot of fancy math speak, but I think once we apply it, this will become a little more obvious. Given the graph, we can reflect on the fact that none of the trig functions we've looked at so far in the previous sections are one-to-one. They are periodic and don't pass the horizontal line test. To be able to talk about inverse functions, we must restrict the domain, which is what I was doing when I was looking at what part of this function I could keep without getting a problem with the one-to-one idea. So I restricted this domain to just the interval from negative pi over 2 to pi over 2 as an example of what I would have to do to the sine function so that it never touches in more than one place for the horizontal line test.